Today on the Ever Forward at 3D Printing channel, we're going to be looking at a very simple and straightforward question. The question is, what can I do with a Revit model? If my designers supply this model of the building, what can I do 3D printing wise with that information? Today we're going to look at the various steps we take to go from a model in Revit to a 3D printed floor plan. Just a few of the things we're going to cover today. What we did with the file we received in Revit, taking that file into another modeling application known as SpaceClaim to further clean up the information. The STL file format is the one that's most commonly used to send to 3D printing, and so that has to be scaled appropriately and turned into another file format called G-code. The G-code is the actual machine instructions. At that point you push print and you see what you get. The project that we printed is in our San Diego region. It's a 4-story building with the intent to divide it logically into 8 areas just for the purposes of sequencing, phasing, and so on. And so our approach with the model was to print each half of a floor as one model. Because the designer's Revit model only contained core and shell elements in 3D, we had to get a little bit creative and find a way to print all of those. For each half of the floor, we only wanted to do a single print. Our best solution is to add floors to represent the corridors and circulation spaces. From there, we just simply 2D print on paper the entire floor plan and then overlay the 3D printed walls. There are a few cleanup steps involved. They're all pretty straightforward, and I'm going to show you most of them. First, I wanted to point out that I removed the work sharing features from the Revit model, which is a trick that we learned last year. This is not strictly necessary to do what you're trying to do, but it did make my life easier to do the rest of this process. Starting with the default 3D view, we begin to remove the extraneous elements, the references, and then we can easily section out just that floor plan that we're looking for using the view cube. Finally, elements that don't belong in the final print, we just select those, and using the Revit feature to hide that category of elements out quickly gets us down to just the information that we're going to take to the machine and print. So currently in Revit, I open up a default 3D view. If I don't have one, I can always hit the 3D view either from the quick access toolbar or from the view menu. I can hit 3D view to create the new default. So what I'm seeing here doesn't quite do justice to the floor plan. That somewhere in this little area is what I care about. Some information has been imported into the file for topography, and it shows up here as something called an import symbol. I'm going to simply left click to select, and I'm going to delete my import symbol, and then I can zoom in. So I'm getting a little bit closer. I've got all this topography, which doesn't really matter to me. So if I wanted, I could do the same thing. I could delete it, or I could hide that category. But what I'll do in this case is I'm getting pretty close. I want to drill down to just the elements that I care about. In this case, I want to see the 4th floor. So I can right click on the view cube, say that I want to orient to a specific view. You can see floor plans, elevations, 3D views. I just want to look at the top floor or level 4, so I'm going to click on that. So I'm still in a 3D view, but what's happened is the system figured out the extents of the 4th floor, and it trimmed out my view just to see that. So what I have now is my 3D view that just indicates the floor plan area that I care about. Many of these walls have been drawn in the style that you would call balloon framing, or it's a single curtain wall element, but even so I'm only seeing the portion that relates to the current floor. Now if there are things that I know I'm not going to try and print, I can select those elements, and then I can decide I'm not going to be able to print this railing, for example. I can select that and say I want to hide not just the one I selected, but all the railings that may be appearing in this view. Similarly, I'm going to take the stair elements and I'm going to hide those. A higher quality printer might be able to handle the stairs, but for our purposes, for kind of the rapid floor plan, we're going to really just focus in on the walls. And so again, I need to connect these various core elements together so that when I print them, it can all be one print. I'm not having to grab individual rectangles and try and reassemble those later. In my floor plan, I've decided to add these floor elements. So I'm going to simply go to my Architecture tab, choose the floor option, and then I'm going to draw it as a sketch. So I'm going to just simply draw lines that represent the corridors. I know where my corridors lay out, so I'm just going to sketch these elements that I know for sure. Once I have a partial corridor created, I can go ahead and click the Finish button. So I'm going to say finish this editing, and this portion of the corridor is created. One important thing to watch out for is that by default a floor will begin at the floor level and its thickness will be represented down, and that's not going to work for us for printing. So simply what I do here is I change the height offset and I make it, if it's a 1 foot thick floor, which it is in this conceptual level, I'm going to say that it's offset 1 foot so that the bottom of this floor will be at the level of the 3D printing bed and not trying to go below, which is not possible. And so I repeat the process and I just create other areas within the plan that represent that corridor using the floor feature of Revit. And although there's a connection here, there's kind of an overall circulation. We made a conscious decision to cut it wherever the two halves of the building model are going to be separated. One other consideration is to thicken the walls to make it easier for printing. In our first attempt, these walls were too thin, and they did successfully print, but they were far too flimsy. So similar to how we can select and hide individual elements by category, we can select a wall, and in this case, something that you would never do if you were designing the building, but in this case I can edit the type properties of that wall, change the structure, and then boost up the thickness. In this case we went from what was about 8 inches to 1 foot 8 inches. And doing this will give us a much sturdier print to work with. The final step in my Revit workflow now is to export the Revit floor plan. So from my 3D view, that's level 4, I'm going to go ahead, choose the big blue R, export, and I want the ASUS SAT file format. So you simply save this file, and then we're going to open this up in ANSYS SpaceClaim. So now I've got the ASUS SAT file that I'm ready to bring in to SpaceClaim. So it's not the SpaceClaim native format, but it reads it pretty much flawlessly. A couple other things I really like about SpaceClaim is that once you have your model there, you really are just sort of working with geometry. There's not all these other properties that are normally involved when you're talking about a building model and an application such as Revit. The cleanup tools for SpaceClaim are ridiculously simple. You can quickly find things that you would never find visually and really clean those up, tighten those things up. And then finally, the ability to direct export to the STL file is great. You can export STL from Revit. You could skip SpaceClaim entirely. You can also export models out of SketchUp. We've done that as well. But in both those cases, in both Revit and SketchUp, it requires some kind of a third-party add-on to get that STL file, whereas SpaceClaim was designed with this in mind. And so what you see here is the interface of the SpaceClaim application. We added one license of SpaceClaim to our list of BIM applications in 2015. And don't let the variety of colors on the screen fool you. That's just how it represents this geometry. So it's very clear at first glance where the individual objects or components in the SpaceClaim model start and finish. The interface is not all that different from Revit. You've got these various tabs and individual tools on the tabs of this ribbon. I think a lot of the geometric manipulation tools are a lot more like SketchUp in a way. You know, you can push and pull it to extrude geometries. So SpaceClaim is a very powerful model creation and model editing tool. All I'm using it for here is to just clean up the information I brought over from Revit. So if I wanted to make changes to the model, Revit was, for me, the easiest place to do that. But now to do some cleanup in a few simple steps, I'm just utilizing SpaceClaim. And the first thing I want to do is remove half of this floor plan. I know I'm going to be printing this in two parts, so I'll come back later to print the other part. But for now, I've reduced this down to just the geometry that we care about for printing. The last thing I'm going to do here in SpaceClaim before creating the STL file, I'm going to select my entire model, everything that remains, everything that's going to be printed. And I can use any of the various repair tools to quickly identify things such as gaps or missing faces for elements of geometry or duplicates. I'll show you what that looks like. And so it looks like SpaceClaim found a number of instances where there's duplication in the model, in the geometry. There's some kind of overlap. Cleaning it up couldn't be easier. I'm just simply going to click right on where I see the highlighted areas. And the software is going to work this out for me. It's going to find the best sort of method of joining, cleaning up these intersections. And with that, I'm ready to move on to 3D printing. I'll simply save, select STL file format to export the file. So the last step, once you've got your cleaned up model, is to bring it into one of the many applications you can use to one, create the G-code file from the STL file, but also two, to just verify various things like size, scale, orientation on the print bed, how much time that print is going to take, and so on. So we'll take a look at a final product coming off the machine. And it turns out that first attempt, despite our best efforts, was a little bit off. I had to rescale that appropriately. A simple ratio tells me that it just was a little bit too small. And once we got that scale dialed in, it was very consistent, floor to floor, obviously, and also to get the two different sides to merge up, we decided, one, to use a different color plastic on either side, but two, we had to be very careful about those points where the two halves of the model would join together. There is just a little bit of expansion that can happen when you're printing with a conventional plastic like ABS. So we were very careful to scale those back just at the interface so that they would ultimately meet up and sit together pretty well. So thanks for checking out this video. I hope you'll also look at some of the others. This is the first in a series of more practical how-tos. We also have some videos that cover various theories and ideas and emerging concepts in 3D printing. Thank you.